This is Radio TV Phono Nut, and sometime back you might remember me receiving a Belmont Cathedral radio that was poorly packed, and the result was the whole front of the radio got cream puffed in shipping. Well, here's the chassis out of that radio. I got my money refunded for the busted radio, but that didn't make the cabinet magically repair itself. I think I can probably mend the cabinet back together if I'm careful, but I don't know that it'll ever look 100% right again. But here today we have the chassis for that radio on the bench, and we're going to try to make it sing to us if we can. Now here's the deal with this radio. It's a 4-tube TRF set, and as you can see, it has a standard power plug and power cord on it, but this chassis is designed to operate on 110 volts DC only. Now, back when this radio was made, there were parts of the country that had DC electrical service. Now, even at that, these types of DC only radios are rare. Back then, the majority of what was out there were your transformer based AC only sets, or your series string AC-DC sets that had a rectifier tube and no power transformer, that were designed to operate on either 110 volts AC or DC service. So like I said, these DC only ones with no rectifier tube in them are rare. I don't know the exact model of this radio, so I had to get on Nostalgia Air and do a little looking to see if I could find a similar schematic, and I did, and here's what we came up with. Alright, here's the schematic, or a similar schematic anyway. We have an RF amplifier stage, we have our detector tube, it looks like a first audio tube, and then our audio output tube. Now each tube filament is 6.3 volts, 300 milliamps, and they're wired in series. And here's what's going on here. We have our incoming 110 volt DC, and it goes through the speaker field coil as well as a 170 ohm resistor through all the tube filaments. The speaker field and the resistor drop the excess voltage for the tube filaments, and then also coming up from the hot side of the line we go through a filter choke, and that's where the voltage comes from for the rest of the radio. So this is a very simple set, really. Now our biggest issue is going to be powering it. I think just for testing purposes, I'm just going to use a bridge rectifier and a filter capacitor and just plug the thing into my Variac and bring it up to about 110 volts and just power it that way. Here's our speaker. As you can tell, the cone is torn. That probably happened during the shipping damage when the front of the cabinet got torn up. Here's the underside of the chassis. As best I can tell, it looks pretty much original. Truth is, this set probably hasn't been used in 70 or 80 years, and we can only hope some dimwit didn't plug it into 120 volts AC, which has been known to happen. They also made some 32 volt radios with a standard line cord and plug on them, and I've got one of those buried around here somewhere that it was obvious someone plugged it into 120 volts AC and did a bunch of damage, so we can hope they didn't do that with this one. Okay, I just checked the off-on switch, the speaker field coil, and the primary of the audio output transformer, and those all have continuity. And this looks like the big can-on dropping resistor. Hopefully it's still good. Let's find out. Alright, is it good? Let's see. Isn't this it? Yes, 190 ohms. That's good. The schematic says 170, but when you're dealing with resistors this old, you expect them to have gone up a little bit in value over the decades. So far, and we have continuity across the power plug that goes away when I pull a tube, so that tells us that our filament circuit is good. Okay, here's our crude little power supply that consists of a bridge rectifier module and a 100 microfarad 200 volt capacitor out of my junk box. AC coming in, radio connected to the output with the ground side of the radio connected to the ground side of the power supply, of course. And we'll just plug this into the variable AC power supply and bring it up slowly until either something smokes or we get 110 volts output on here. Alright, here we go. I might want to bump the meter up to the next highest range. Alright, there's 50 volts. We'll let it sit there for a little while. Okay, I'm up to 90 volts, and I'm getting noise out of the speaker. We're connected to the long wire antenna. But no station, just a bunch of popping and carrying on. Whoop, there's a station. Come on, come back to me. We'll just leave it right there. Alright, 110 volts. So we're getting a little activity, and that's a good sign. I think the next thing we need to do is clean the volume control and clean the tuning condenser with our control cleaner. That might take care of some of the issues. Okay, I got some cleaner in the tuner and the volume control, and we're waiting on the tubes to warm up. And in order to get 110 DC out of our crude power supply, I'm feeding it with about 60 volts AC input, and that's working nicely. Alright, we're warming up. That's good. Let's see if we get anything now. Get this out of the way. That wire's kind of in the way. And it's still kind of erratic. Let me play with this and try to get it back on a station, and then we'll go from there. We may have to take this tuner apart and clean its contacts more thoroughly. Well, if you're going to land on a station, I'd prefer you land on a talk station. I don't need copyrighted content on here when I'm trying to troubleshoot this thing. Well, right now that's the only station we can get to come in, so it's just going to have to be that way, and the copyright police can just bite my butt. Alright, now I want to check some of these capacitors. I suspect some of these are leaky, and I'm just going to look at the ones that have high voltage on one end and pull one end loose and see what we got on the other end. Alright, I'm checking at this big honking bypass capacitor. One end connects here and the other end connects to ground. We have 11 volts on that end. Let's cut it loose and see if the voltage jumps up. It looks like the longer it stays on, the more the voltage drops. So let me just cut this joker out and we'll see if it comes up. Hang on a second. Get my pliers in here to it. Nope, well, it went up a little bit. Now let's see if we have any voltage on the other side of it. Yes, we have 11.4 volts on the other side of it, so that capacitor is very leaky. And this sprayed cap, it's a 0.5 microfarad that one side connects to the B+, the other side connects to ground, and on the ground side we have about 90 volts with 107 going into it, so yeah, that cap's leaky too. The schematic calls for a 1 microfarad. They have a 0.5 in there, and it looks original, but like I believe I've already said, I don't think this schematic's for this radio. It's the closest one I could find for it. So we'll just replace it with what was in there and be done with it. And our plate to grid coupling cap for the audio output stage. We have DC passing through that we shouldn't have. Got 51 volts on the plate of the first audio tube. That's probably about right. And the grid bias resistor for the audio output tube is supposed to be 300K, but we're reading over 700K. 731K, 730K to be precise, so that needs to be replaced. Okay, this is our cathode. The cathode bias resistor is supposed to be 1200 ohm. It's up to over 1500. Not a big deal, but we know it could go higher, and all I have is a 1500 as a replacement, so we're going to replace that. I just showed you the 330K grid resistor. It was way up. This coupling capacitor needs to go, but here's the deal. They're using this terminal strip for mounting, and this is the ground lug, and the only way it's attached to the chassis is it's riveted here, and as you can see, it's kind of loose. And we know after 80 or 90 years, these chassis tend to oxidize and stuff and not make a good ground connection, so I scraped this clean, and we're going to solder this to the chassis, and that way we'll have a good solid ground connection here. And there we are, a nice secure ground connection. Alright, I'm in the process of replacing this coupling capacitor that couples the plate of the detector over here to the first AF amplifier. I'm checking the plate voltage on my detector tube, and I'm getting about 6.8 volts and dropping. It was about 12 when I started, so I don't think that's right. So let me go back through these resistors and see if I can find where we're losing it. Well, we got 15 on the other side of that resistor. Let's go back to this resistor. What do we have? Ooh, 108 volts on the other side of that resistor. I wonder if that resistor here, we have 108 volts on one side and 15 on the other side. Let's see if it's gone way up in value. This resistor looks to be 300K. It's kind of cruddy looking. I'm on the 20 meg range on my meter, and I'm not getting diddly jack. So that right there could explain the reason we had very poor reception. I bet if I change that resistor, I bet the B+ voltage will jump back up and we might have better reception. And this other 300K resistor that goes from the plate to the junction where the open resistor is reading, stay on there, about 1.4 meg, so both of those need to go. Well, now I get it loose, and now it's decided it's going to read something, 572K, but that's still out of tolerance, yeah. And this other resistor is still 1.2 meg, so yeah, both of those need to be replaced, and I think our B+ will then come up to an acceptable level. And this 1 meg resistor that connects to the plate of the same tube we're working on. The detector tube is up to 6 megs. So yeah, this thing's got a real resistor problem, seems like. Well, even after changing all of those crap out of tolerance resistors, voltage really still didn't go up none. So I guess that just goes to show that a lot of times the resistors in these things can be way off and it'll still work. I don't know what size that honking capacitor is that came from the, was used as a cathode bypass for the output tube, but it was a 4.7 in that RCA TRF set. And that seems to give us a little more output, so we're just going to go with that value. Okay, like I said, I don't have a schematic for this, and it's obvious the one I have isn't the correct one. There are 3 things here. This thing, and one back over here. When I first glanced at them, I thought they were some kind of coil, but they don't read any continuity. And then the more I look at them, they look like a capacitor. Well, I have this one disconnected. I don't have any voltage on the other end of it, so it's not leaky. But with it disconnected, whatever it is, it makes no difference in the as you can see, there's no change with it in or out. So if it is a capacitor, it's open. Okay, now we'll substitute a 0.22 for this capacitor. No dramatic improvement, but I can tell a little bit of a volume boost, which I wasn't getting with the old capacitor. And I measured the old capacitor on the standard low voltage capacitance meter, and it reads 0.19, so we're going to say that it was probably supposed to be somewhere in that range, but I don't know. I'm just guessing, because like I've said 3 or 4 times, I don't have the right schematic for this radio. I wished I knew the model number of it. Maybe I could find something. And they weren't too good at printing the values on some of these old parts, so there you go. Okay, I have these 2 caps tacked in temporarily just to see if this is what I really need to do or not. And I finally got it back on 910. This tuning condenser is very touchy. I'm starting to wonder if this thing was even worth messing with or not, given the cabinet's destroyed on it, but anyway, I went up and did some more looking. I cannot find anything on this model. In fact, I don't even know what the model really is. I did some looking on the internet and found a scan of an old Sylvania book that matches radio model numbers based on tube complement. I found a Belmont that was close, but not exactly the same as this one, a Model 450. And there was not even that model listed in the Riders Index on Nostalgia Air. I couldn't find any model listed that used the exact same tube lineup as this one does, and I know it has the right tubes in it because the numbers are stamped on the tube sockets. So I think this one we're just going to have to wing it and do the best we can, and if we get it working, great. If we don't, you know, we can throw it in the parts pile because the cabinet's pretty much destroyed and I got my money back on it. I hate that it's turning out this way, but you know, what can you do? Not that this cap would have any effect on the overall operation of the radio, but this is the isolation cap that connects the external ground connection for an antenna system to the chassis. It says on here Potter Master Bypass, and it looks like a 0.1 microfarad. And since it looks just like those other 2 things, I assume it's the same device. So I'm going to put some high voltage on one end of it and see if we get any leakage. Oh yes, it's leaky as all get out. More like shorted. On the meter, it's pretty much showing open, but we know an old leaky cap will behave a lot differently when you apply high voltage to it than it will when just checking it on the ohm scale on your meter. This one, I'm up on the 2 meg range, and I got a little bit of a reading at first, but as it charged, that was the end of it. So if this cap's leaky, sure the other two are too. Or let me rephrase that. The other two are as well. Okay, I removed the other two capacitors, hoping there'd be a label on the bottom end of them, and there was not. So since they were about the same physical size as the other one, I just went ahead and replaced them with 0.1s. I don't think it's going to increase our volume any as far as station volume, but it may cut down on some of the squealing and oscillation. And let's play with this flaky tuner and try to get one of our local stations to come back. Okay, I have the signal generator connected, set to about 1400 kilocycles and turned as high as it'll go. And this is what's happening. You can hear we are able to blow a signal through it, but when I turn the tuner, you hear how it's cutting in and out like the tuner's making intermittent connection. And it sounds like when it's working, we're getting a signal overload on the front end, but we're not getting much volume out of the speaker. So I'm thinking we have two problems, a flaky tuning condenser and an issue with the audio output. Well, I see one problem with our audio. Looking at the speaker, I noticed the voice coil wasn't even moving. It's not even attached to the, the cone is not even moving, and it's not even attached to the voice coil. It's all rotted away here. So I'm going to just disconnect this speaker and temporarily connect another speaker and see what happens. Alright, that's better. Alright, that's minimum volume. And that's maximum. Okay, I clipped this mica capacitor loose. One side connects to the plate. The other side goes over here. Where does it go? We'll find out in a minute, but anyway, when I clipped it loose, I'm getting a little DC on the other side of it. Let's see. I hope these sounds are not copyrighted. Whoops, that's the wrong end. See, we're getting about a half a volt there. And on the plate side, we're getting 57, 56 volts now. I found another faulty ground connection where this capacitor connects to this pin on this tube socket, which in turn goes over here to this ground lug that's bolted to the chassis. I'm getting about 16 ohms. Now when I go direct to the chassis, from one part of the chassis to the other, I get 1.5, but 16 ohms on this other side over here, so we're going to have to do this one just like we did these other two, sand this and solder the crap out of it. Okay, we soldered our ground lug to the chassis, and now we have 0 ohms, just like we're supposed to have. Okay, I replaced the mica capacitor that was a little leaky, and there was a 50K resistor that read 70K. I don't think that would make much difference, but I went ahead and changed it while I was out. Put a 47K in there, and as you can hear, it's still doing the same crap. Yeah, I'm about ready to throw this thing in the garbage. The cabinet's a wreck. It'll probably never be right. And I don't like these sets that no matter what you do to them, they just seem to not work right. Okay, what I'm going to do now is pull each tube out and see if I can determine where the interference is coming from, what stage it's originating from. And since these are series string, we'll have to act quick before the rest of the tubes cool down. Here's the RF amplifier tube. The motor boating's still there. Alright, let's pull the detector tube. It's still there. Pull both of them out, it's still there. Pull the first audio tube. Audio amplifier tube, well, I expected it to. But I think it's getting in somewhere right in here at between the detector and first audio stage. Okay, I think part of the problem is there's junk getting in on the AC power line. I have a capacitor, a 0.1 microfarad capacitor connected from one side of the line, and when I touch it to ground, it doesn't get rid of the crud completely, but it diminishes it a great deal. That's without, that's with. Okay, I improved things a little more by installing a 10 microfarad film capacitor across the 0.5 microfarad that goes from the output side of the filter choke to ground. And this tuning condenser, the reason it was erratic is you have this brass spring piece of whatever, spring steel or whatever it is, it serves as a contact. It was not making good connections, so I tried to solder it as best I could to the frame of the tuning condenser, and it seems to be working less erratic now. Well, turning the antenna control, gain control all the way down, we have no more motor boating now. However, we still have this pesky modulation hum. However, I can reduce that by grounding the radio to earth ground here. Alright, we're grounded to earth ground now, and it's better, but there's still some squealing and crap going on. As I increase the volume control. This mumble gospel music.
And they like working. VDC Twitter handle the swollen rocket man. Give me the over on here. They're giving back to their community.
1450, 1390,
is really important.
1010, and 910. Only good thing here is we don't have an erratic tuning condenser anymore. But the performance of this radio is very lackluster. I think if I had a pure DC source, such as from a battery, that had no connection to the AC power line, this might work better, but this is not too good. Alright, if I bypass the cathode of the detector tube with a 0.1 capacitor, that helps a great deal.
The Prince of Darkness.
Alright, here's the cathode bypass capacitor in place.
Jonas was always when I was doing radio, so this is a little mini reunion here on FSR. Good to be with you.
It just shows you how bad things are. We have 1450 that's a sports station, and we have 1010 that carries sports in the afternoon. The problem is they're both carrying the same program. You would think 1010 would branch out and be more creative.
Right now. Anyway, Jonas, because that's your handbook. But of course, the fact that is, going on.
And as I turn the antenna volume control, no more squealing.
We're so starved for.
Alright, this is about as good as we can get it, and we're now to an acceptable point now. Now the little hum you're hearing with the volume all the way down, that's 120 cycle ripple from the little crude power supply that I've hacked together to run this.
Minutes ago when I told you that.
But we're on 1010.
The conversation about Jameis has been about the turnovers. You know, Jameis once can play with a broken thumb.
And I found a better speaker that sounds better. So.
Yeah, but Bucky, this is what I've been trying to tell you. People don't care.
Right.
I've been trying to tell you.
There's our mumble gospel station.
What are we talking about here?
I know.
All right.
Gospel Radio, 1390 AM and 93.1 FM. WMER is back with more of your gospel favorites next.
That U.S. Navy hospital ship being rushed back into service to provide medical help to New York City, now the epicenter of the disease outbreak.
Ben Mallon and I were talking today on our podcast.
And there's 1450, the sports station, but like on the other TRF radios that we recently repaired, 1390 kind of bleeds over on it.
Send off. The ship has 12 operating rooms, as well as radiology suites and a CT scanner. It also has ICU beds.
And that's with the volume all the way down and 1390 blasting in.
Considering a quarantine affecting residents of the state and neighboring New York, New Jersey, and Connecticut amid the outbreak. And former Republican Senator Tom Coburn of Oklahoma died this morning. He had been diagnosed with prostate cancer years earlier.
Is that Lee Exotic again? Yeah, Lenny Dykstra, very open about his steroid use, huh?
Yeah, he was open about it, talking about it with Barry Bonds.
Now when I remove the earth ground...
Listen, we don't have proof that Barry Bonds did steroids.
Come on, get off of there.
He never tested positive.
We get a little bit more interference now.
People say to go all the time. Later
earth ground and the
later life
noise goes away.
Careful, Bucky.
I'm just saying.
This damn quarantine's got the best of you.
Doing the sandwiches from last week.
Oh, boy. Here we go.
Okay. So in order to power this thing and get satisfactory results, number one, I'm going to have to build a better power supply than the crude little thing I have down here. We're going to need a beefy transformer with about a 60 volt secondary, bridge rectifier, filter choke, filter capacitors, and that might get it clean enough that we can run this set. Probably the best thing to do with this set is to mount an onboard power supply. Use a standard transformer with a 6.3 volt filament winding and a high voltage winding. Wire all the filaments in parallel and just build a standard pi-type filter network and bridge rectifier for the high voltage. Now I know this is a rare set, but when you consider the cabinet front got bashed in, it's never going to be right anyway. So if I decide to go further with this, I'm probably just going to build a little power supply on the chassis itself, and I'll have room to do that, especially when I remove this filter choke. I can probably put it under the chassis and put a small power transformer on top here.
Wide receiver.
The speaker, I may or may not have it reconed. I don't know. What I do to this will be determined by how well the cabinet turns out. If I can get the cabinet looking decent, I might have the speaker reconed. I don't know. But we accomplished our mission with this video. We wanted to hear this chassis play somewhat reasonably well, and we have done that.
The vending machine, I was there. Yeah, that is.
The ultimate in mumble gospel. Well, when it gets a little bit later, we'll do a band scan and see if we can pick up any out-of-town stations. But right now, I'm going to go over what modifications I had to make to cure this radio of its ailments. I know this video kind of jumped around a little bit, and we had several ailments taking place at the same time. Low-frequency oscillation, as in motorboating, high-frequency oscillation, modulation hum, noise, interference, you name it, we had it. Well, first, let's look at the bypass capacitor that connects from the other side of the filter choke to ground. You can see it right here on our schematic, which is not the same as this radio. It was a 1 microfarad. The one installed in this set that looked factory original was a 0.5. Well, that might have worked for a 1930's DC power line, but it wasn't working so well for us today. So fortunately, I had a 10 microfarad film capacitor on hand, and that took care of all of the motorboating. I tried using a lower value like a 1 and a 2 microfarad, and that helped, but we still had motorboating at the low end of the volume control. So you're probably asking, why did you use a film capacitor instead of just a regular 10 microfarad electrolytic? Well, the reason for that is if someone connects this radio to a DC source and gets the polarity reversed, that polarized electrolytic capacitor would have gone pop. This film capacitor is non-polarized, so if you hook the radio up backwards, there's no chance of it blowing up. And I'm just glad I had this capacitor on hand. I think that's a carryover from when I needed a 10 microfarad capacitor for a capacitive dropper to replace the line cord resistor in an old 30 series string set. I ordered 2 of them, so I'm glad I did now. The next problem we had was high frequency oscillation, and that was a bit of a trial and error nightmare to get rid of, but we got rid of it. The schematic for the radio that's not like mine shows a 0.25 microfarad capacitor from the cathode of the detector tube to ground. This one never had such a capacitor. Once again, that might have worked out okay for a 1930's DC power line, but not today. I first went with a 0.1, and that got rid of all of the squealing and undesirable crap, but I just upped it to a 0.25, and that seemed to work okay. Just a little extra margin of safety there. Another thing we did that seemed to help overall was add a 0.1 microfarad safety capacitor between one side of the incoming AC line to, and the other side of the capacitor connected to chassis ground. And then that helped tremendously, but we still had some modulation hum and a lot of interference. So I just connected the antenna ground lead to the earth ground here of our oscillation transformer / variable AC power supply is connected to, and that seemed to have helped that. Now I'm pondering in my head what to do about a power supply. You're not going to believe this, but apparently the dial bulb in this set is even connected in series with the tube filament, so if the dial bulb burns out, guess what? The radio doesn't play. And on that note, I understand this is a rare set. Not many of these DC-only table radios were made, and I'm all for keeping the design as original as possible, but I'm also for making these sets, shall we say, plug and play, where you can just plug them into a modern AC power line and use them. And like I've already said, the front of this thing got cream puffed in shipping, which I think I can make it look presentable, but it'll never look right again. So what I'm thinking about doing, I think Antique Electronics Supply sells a power transformer. Now, mind you, we don't need no 300 volts of B+ and high current here. All we need is something that'll give us around 110 volts B+, and I need a 6.3 volt filament winding because I'm thinking about wiring all of these tubes in parallel, the tube filaments in parallel, and then of course wiring the dial lamp in parallel with the tubes and using a standard 6.3 volt dial bulb. And then I can use the high voltage winding off of the transformer and feed that into a solid state bridge rectifier, and then use an appropriate filter capacitors and filter choke. I can probably use the choke that's already in the set, maybe, I don't know, and get about 110 volts B+, and then we should be able to plug this radio into any standard 120 volt AC outlet and use it. As far as the speaker, I don't know what I'm going to do about that. There again, a nice old original speaker looks better in a set than some modern 21st century Chinesey thing, but there again, I'm looking at cost, and I'm looking at, once again, how badly this radio cabinet got damaged, and you know, it's never going to be a pristine original example, so I may have the original speaker repaired. I may just replace it with a modern PM speaker and be done with it. Well, it seems like the 910 gospel station now has an FM translator, and I think there's only one AM station around that doesn't have an FM translator, and that's 1010 WMOX. 910 has one, 1390 has one, and 1450 has one. Now, I know a lot of people in the broadcast, in the vintage radio community, and on the I Love AM radio group on Facebook, seem to frown on stations having AM stations having FM translators, and I have mixed emotions about that, but I know in some areas there's actually some AM stations that broadcast some decent music, and that probably wouldn't happen if it wasn't for them having an FM translator. So if it possibly means that some AM stations will now start running some decent programming because they have an FM translator, then I'm not going to complain about it. It's just unfortunately none of the ones in my area offer any programming that's to my liking. Your choices are either black gospel, news talk, southern gospel, or sports. Take your pick. Okay, it's about 8 o'clock at night. probably WWL, but that's about all I'm getting at the
Our veterans
lower end of the band.
to learn more about how you can help. AM 1010, WMOX Meridian.
I found a speaker.
Special reports. Coronavirus update.
It's the same size as what came out of it, but it's a crappy sound design speaker out of a stereo I junked, so I'm going to try to find something better.
Fairly soon. Minutes ago on Twitter, he did announce that a quarantine will not be necessary. The president. WDIA, Memphis. For independence at no cost for life. So now it's time for a grateful nation to step up. Join us at findwwp.org.
No matter who we are, or where we come from, we all experience.
And call 1-800-GRAY-BAR. Believe it or not, it's time for spring cleaning. You're not the only one who's tired of winter this year. Your carpets are too. Think about
It seems like the upper end of the band is more active.
with nowhere to go. There's only one. This is something that'll slowly be wrapping down as we head overnight. It's going to be a big storm.
Arkansas's governor today signing into law a bill establishing a COVID-19 rainy day fund. That state has more than 400 coronavirus cases, 5 deaths so far, 2 more today. New York State hardest hit, 52,000 coronavirus cases with more than 700 deaths.
There's an old expression. You go to war with what you have, not with what you need, which is true. When the bell goes off and you have to go to war, you deal with what you have because it's too late to do the preparation.
Governor Andrew Cuomo not liking this. President Trump's proposal to quarantine New York, New Jersey, and Connecticut. America's listening to Fox News.
WOAI Local News.
The University of Texas is not planning to reimburse students of spring semester tuition due to coronavirus. UT Austin says funds for student activities and support.
History, culture, and faith will converge right before your eyes.
And now we're coming into 1390. That's going to overpower everything on the upper end of the band.
This December, we'll pray at the ancient Western Wall, sail the picturesque Sea of Galilee, float on.
Even when I turn the volume all the way down, you can still hear it.
Best of all, we'll be together with like-minded supporters of the nation of Israel. Reserve your spot today and travel with me on the Sands of Israel tour. Visit sebgorka.com and click on the Israel banner. That's sebgorka.com, sebgorka.com.
Somebody has made a horrific mistake.
And I think this one only goes up to 1,500, so...
77% of white evangelical Protestants are confident that Mr. Trump is on the right track and taking the measures he can.
I'm Zach Babb, News Radio 1200 WOAI.
Mostly clear skies, diesel.
Evangelical groups give President Trump's virus plan a thumbs up.
A new poll from the Pew Research Center reveals that 77% of white evangelical Protestants are confident that Mr. Trump is on the right track and taking the measures he has to stem the spread of the coronavirus. 62% of white mainline Protestants also have faith that the president is doing the right thing. In fact, within America's religious communities, President Trump's political opponents are the only ones who are generally taking a dim view of his fight against the virus. Michael Harrington, SRN News.
Patrick Rooney of the Indiana University Lilly Family School of Philanthropy says individuals making less money at this time will generally cut back on their charitable donations. He cites the recession of 2007 and 2008 as examples. Total giving dropped by 7% in 2008 and decreased by another 8% the following year. This is SRN News. Stars of the 2011 virus thriller movie continue.
Okay, this is a religious station. I can't remember the call letters, but...
But if you're an NFL player, an NBA player...
6460, 800-343-6460, 800-343-6460. Some restrictions apply. For complete details, please visit OptimaTaxRelief.com.
As you name it. I mean, I'm sure I'm leaving out so many different groups, but I think the draft...
Association contractors from the station.
For 97 years, we've been here for you. The biggest life-changing events.
And we're here for you now.
Depend on us.
WBAP coming in faintly.
It's important that we understand what both sides are saying. It's important that we understand, like the guy from Alaska.
And I forgot to mention, as far as converting this thing to AC, these tube filaments will operate on AC or DC, so that won't be a problem. We can run we can get a transformer with a 6.3 volt filament winding and run the tubes on that, and a high voltage winding to rectify and filter for the B+, and we ought to be in good shape. Some Spanish station. Another Spanish station. There's WSM faintly coming in. I figure when it gets a little later, it'll come in better. Okay, that ought to about do it. When I get ready to do the AC conversion, we'll do a video on that as well.
Right? And so we just gamble more. So if I got...
Wiser Nitro Gold. A lager brewed with nitro for a silky smooth finish. As smooth as my voice. So smooth you'll enjoy hearing me read the legal disclaimer. Enjoy response.
KMOX.
The greatest of which deserves special recognition.
Less than 10 minutes. But how about this?
All right, there you go. That ought to do it.
Michael Brockers. He's a defensive tackle.